In this session, for the 8th standard CBSE Mathematics on the topic cubes and cube roots, we will learn how to solve some questions from a sample question paper. We will see the concepts of cubes and cube roots, the table of cubes from 1 to 20, and a few concepts of cube roots, and then try to solve a few questions from the sample question paper. Let us go into the session. Made up of 6 faces. It has 3 dimensions. Dimensions are equal. What is the volume of the cube? Side into side, edge, that is, you take the edge into edge, let us say. Length into breadth into height. So it is A into A into A, let us say. A cubed then is equal to 64. So we have to take the cube root of 64. Let us see what the cube root of 64 is from the table here. We have the table here. The cube root of 64 is 4, because 4 cubed is 64. Hence, the cube root of 64 is 4. Here is a table of 1 to 20, the cubes of 1 to 20. Cube 1 ends in 1, 2 ends in 8, 3 cubed ends in 7, 4 cubed ends in 4 itself, 5 cubed ends in 5, 6 cubed ends in 6, but 7 cubed ends in 3, 8 cubed ends in 2, 9 cubed ends in 9 itself, and 10 cubed ends in a 0. Based on this concept, we just go through the 11 to 20 also. When a number ends in 1, the cube of that number will also end in 1. When the number ends in 2, the units digit, the ones digit of the cube of that number will be 8, because 2 cubed is 8, no? And for 3 cubed, when the number ending in 1 in 3, 3 cubed is 27. So the cube of that number will also end in 7. So like that, we go on to this table. 19 cubed ends in 9, 18 cubed ends in 2, and so on. So need not memorize all these values. A few typical values we can remember easily. Example, 3 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, and 6 cubed. 6 cubed, 7 cubed, and even 8 cubed, you can just remember. Up to 10 at least. Then we go on to cube roots. If you take the cube root of this, cube 12, it ends in 2, so it should be 8. 216, it ends in 6, and therefore it should be 6. The cube root of 343, the 3 ends in 3 and ends, the cube root should be 7. 27, the cube root of 27 ends in 7, so it should be 3. The cube root should be 3. And 9, here 729 is 9. Ending in 0, it will be 10 again. So these are the standard things about concepts of the cubes and cube roots. Now let us learn how to solve some questions from a sample question paper. Get started. Just, I will show you the question paper and you can just watch. This question paper consists of multiple choice questions as well as paper here. It's taken from the Kendriya Vidyalaya school practice paper on the chapter cubes and cube roots. First question, section A consists of 6 questions of 1 mark each. This question paper, we can easily see that this is a cube root within a cube root. The first question. Let us move on to the first question. The cube root within the cube root. Here we have the cube root of 343, which is, we know it is 7. So we can write that 7 directly there. 1 doesn't change. 1 plus 7 is 8. And the cube root of 8 is 2. That's it. And the answer is the A option, 2. So when there is you have a radical symbol here, the square root symbol, when you don't put anything here, the small number you see there, it is 3 there. So it's a cube root. If nothing is there, it's a square root. We don't usually put that 2 there for a square root. For other higher order roots, we put the number, corresponding number, 4th root and so on. But cube root, we put 3 there. A small number 3, which appears here, refers to the cube root. Second question, the smallest number by which 675 is multiplied so that the product of a perfect cube is, we have to, the product of a perfect cube, product is a perfect cube. See, if you want to multiply 675 is not a perfect cube. Though it ends in 5, it is not a perfect cube. But to make this a perfect cube, we should make it end in 5. So the smallest number should definitely be 5 only. Because the cube root of the last digit ending in 5 should be 5 itself. Should also end in 5. So we can say that if you multiply 675 by 5, it will end in 5. And it will be a perfect cube because if you multiply this 675 by, you can do this by prime factorization on all, takes a lot of time. So among these, the smallest number, because if you take 3, it will also end in 5, but it will not be a perfect cube. So check that. That is enough. The other 2 are larger numbers. Among the 2 smaller numbers, we have 3 and 5. So only these 2, among these 2 can be the correct answer. So we choose the 5 here because 5, if you multiply by 5, you can check that it's a perfect cube. You can also find the cube root if you want. It's not necessary here. Third question, which of the following numbers is not a perfect cube? We know 343 from the table. We have memorized a few table 125, 216. For 567 is not a perfect cube, though it ends in 7. So 216, we know it's 6. 125, cube root is 5. 343, the cube root is 7. That's all. So we know from the standard table of cubes. So we can find out, and therefore it is 567. This is not a perfect cube. We move on to the fourth question. It involves decimals. To find the cube root of, it is given that 185, the cube root of 185,193, 1,85,193, the cube root of this is already given. It is given as 57. And we have to find the value of this cube root of this number plus the cube root of 185.193 and also plus the cube root of 0.00185,193. Let us see, evaluating this first part. First, 185,193. The cube root is given, so it's 57. So we write it as it is, plus, we put plus here. 185, the same digits appear here, 185,193, but the decimal point is in the 3rd place. So when there are three decimal places, we have to take only one decimal place. There will be only one decimal place in the cube root. For every 3 decimal places, there will be only one decimal place in the cube root. So it is 5.7. Because 57, you take one decimal place, it will become 5.7. But if you take this number, 0.000185,193, how many decimal places are there? There are 9 decimal places to the right of the decimal point. So for every 3, this 1. So there are 3 decimal places, take 1. Another 3 decimal places, take 1. And another 3 decimal places. So there should be only 3 decimal places in the cube root. 0.057. We know that it is 57 already there, this number. So it should be 0.057. Add all these numbers. You will be getting 62.757. And that's the answer, D option. Moving on to the 5th question. The 5th question, there is a evaluation of a complex cube root. It's all are perfect cubes. Very easy. All are perfect cubes. 64 cube root of 64 is 4. Cube root of 125 is 5. And the cube root in the denominator, the cube root of 27 is 3. Thereby you get 4 plus 5, 9. 9 divided by 3 is 3. Therefore, the option B is the correct answer. That's all. Now, the assertion reason questions. Should be careful while you answer this assertion reasoning. The option given here are, if the A option is both A and R are true, and R is the correct explanation of A. Now, the statement A states, assertion is a statement, and the reason is the explanation, justification, or rather justification for the statement. Let us see how. The ones digit of, or in the cube root of the cube number 1728 is 6. But it is false. We know that if the cube of this cube root of 8 should give a 2 there. The cube root of 8 should be 2 there. So the ones digit should be 2 rather than 6. So it's a false statement. So straight away we can go to the D option, because there is the only option that says A is false. A is false, but R is true. Such things you can easily diagnose the justification. So because the ones digit in the cube root of a cube number is 2. 8, if you take the cube root of 8, it will be 2. So it should end in 2, not in 6. Okay. But R is true. If you see the R is there, it is, the reason is true. Even without reading it, you can see it, because that D option is the correct answer. That's all. B, section B questions. Section B questions, the solutions are given there. It's quite easy, because to find each side of a cube, we have to take the cube root. 512, you know the cube root of 512 is 8. 8 into 8 into 8, cube root is 8. So 8 centimeter is the each side of the cube. What is the smallest number by which 1323 may be multiplied so that the product is a perfect cube? First of all, we have to resolve 1323 into prime factors. Since odd number, we start with 3. If it's an even number, you can start with 2. This is how you go about resolving into prime factors. Look at the number. If it's an odd number, start dividing by 3 first. If it is divisible by 3, you know it is divisible by 3. Till you get another odd number which is not divisible by 3, try 7 then. Because 5 the number should end in 5 or 0. If it doesn't, then it should be divisible only by 7, the next prime number, and so on. This is how you start doing till you get a quotient as 1. Keep on dividing. You get a triplet here. You get a triplet of 3. 3 is a triplet. Triplet means there are 3. The 2 means it's a pair. There are 2 factors. It's a pair. You find 7 and 7, they form a pair. There are only 2. But 3 has a triplet, so it's a perfect cube already. So that 3 is already there, but 7 is not there. 1 7 is missing. If you put 1 more 7, multiply by 1 more 7, it becomes a perfect cube, isn't it? That's all. And the cube root will be, it's a perfect cube, and the cube root of this number would become 7 into 320. 7 into 3. This is not a perfect cube. This 1323 is not a perfect cube. One more, you have to multiply by 7 to make it a perfect cube. And that perfect cube will end in 1. So 21 is the perfect cube, the cube root of this number. But that is not asked here. It's just asked to find out which to be multiplied, which is the smallest number to be multiplied, and it is obviously 7. Moving on to the 9th question on section B. These are all 2 marks questions where you have to work out and 1375. What is the smallest number by which 1375 should be divided so that the quotient may be a perfect cube? This is again prime factorization. Since it's ending in 5, the number ends in 5, so we divide by 5, continued division, till we get an odd number, another odd number, which has to be divided by 11. Finally, 5 has a triplet. 5 is a triplet actually. There are 5, 5, 5, 3 5s. So it's a triplet. 11 is left out. So you have to divide this number by 11. That's all. Simple. You should divide this because it has only one 11 there. If you divide by 11, this becomes a perfect cube. It will be, in fact, 125. The cube root of that number, the number itself will become 125, and the cube root is 5. Very easily you can do that. So prime factorization is the best way to solve these such problems. And one which is left out here, there is only one 11, so we have to divide by 11 and hence make it a perfect cube. Understood? We move on to section C, 3 marks questions. Sujata makes a cuboid of plasticine of 5 into 2 into 3. This is a similar question has been asked in the NCERT textbook. And we have worked out such questions before, but still we see length into breadth into height of the cuboid gives the volume. L into B into H. We are given all the 3 dimensions of the cuboid. 5 into 2 into 3. We need not multiply. We keep it in the exponent form itself, just like that. It's not a perfect cube at all. To make it a perfect cube, what it should be done? That's all we need to do. What is to be done? We have to multiply by 1 more 5 and 2 more 2's. See, we have to multiply by 5 into 2 into 2. So, if you multiply this by this number, this 5 triplet has come. There's only 1 2, so we should multiply by another 2 more 2's into 2 into 2. So, to make it a perfect cube. So, you'll get 5 cubed into 2 cubed. So, for that, so if you multiply this number by 20, you will get a perfect cube. So, it will become a cuboid. It will become a cube. So, that is the number of cubes, number of cuboids. The 20 number of cuboids has to be, because when you multiply by 20, it becomes a perfect cube. Multiply this cuboid, the volume of this cuboid by 20, you get the volume of a cube, which is a perfect cube. That's why it's to make it a solid cube, isn't it? This is an easier way to evaluate, but there's another way where you can work out in step by step by dividing. There's another way where you divide the volume of divide the volume of the cuboid. This cuboid is there. If there are n cubes, then we have to divide a cube. Forming a cube is having, we have to make it a perfect cube first. In order to, it will be 1000, I think. In this case, it will be 1000. We have to multiply this and make it a perfect cube. So what is the volume of a cube that will be formed? That will be 1000 centimeter cube. That if you divide by this volume of each cuboid, you will get the same 20 number of cuboids. That's all. So this is also another way of doing. 11th question, to evaluate this expression. All are cube roots. You see, cube root of 27 is 3. Cube root of 0.008. You know that cube root of 8 is 2. How many decimal places are there? There are 3. So you should take only one decimal place. So 0.2. Okay. There are 3 decimal places in the number 0.008. So for every 3 decimal places, the cube root should have only one decimal place. So then the cube root of 8 is 2 means you'll have 0.2. You should have only one decimal place in the cube root. Similarly, 0.064. 64, the cube root of 64 is 4. We know that. And there are 3 decimal places in the number 064. So there should be only one decimal place in the cube root. Hence, it is 0.4. We add all these 3 numbers. 3 plus 0.2 plus 0.4. The answer is 3.6. And that's the answer. 12th question. The cube root of 4 and 12 by 125. This is rather a tricky question. You have to first convert this into an improper fraction. This is a mixed number, mixed fraction. You convert this into an improper fraction. How do we do that? We multiply this whole number part by this denominator. Do we do that? How do we do that? We first multiply 4 into 125 and then add 12 to that resulting number. If you multiply 4 into 125, you will get exactly 500. And if you add 12 to that, you'll get 512. And the denominator remains the same, 125. It's very easy now. The cube root of 512 is, what is it? 8. Because you have 2 cubed into 2 cubed into 2 cubed. 2, 2, 2. So 2 into 2 into 2, 8. That's it. And the cube root of 125, we already know it's 5. So 8 by 5 is the answer. We got it very easily for a 3 marks question. By what, 13th question, by what smallest number should 3600 be multiplied so that the quotient is a perfect cube? Also, find the cube root of the quotient. It's easily already done this before. 3600, the prime factorization again. Whenever there is no triplet, see 2 cubed, see 2 into 2 into 2, already a triplet. And 3, there are only 2 3s and 2 5s. So 1 3 is missing, 1 more 5 is missing. And we need 2 more 2s. There's only 1 2 in the second triplet. One triplet is already formed there. 2 into 2 into 2, but there is only 1 2 there. Another 2 into 2 is required there to make it a perfect cube. So we have to you have to multiply this by another 2 into 2, 4 into 3 into 5. 2 into 2 into 3 into 5, that is 60. So we have to multiply this number by the 3600 by 60 to make it a perfect cube. 3600 is not a perfect cube. And we move on to the section D, which is a 5 marks question, 4 marks question here, or sometimes it's 5 marks. Section D questions carry either 5 marks or 4 marks. Here we have, again, the same question is repeated here. But the thing is that we have to find additionally, we have to find out the cube root of the product. So in addition, we need to find the cube root of this. Means we can take 2 into 2 into 2 into 2 into 2 into 2. There are two triplets in 2. See, 3 and another 3. So you take 1 1 in each. For every 3, you should take 1. That is the cube root principle. That is the easiest way. For 3 2s, you take 1 2. That is the cube root. Another 3 2s, you take 1 1 2. So 2 into 2. 3 already a triplet, and 5 is also a triplet. So 3 into 5. So 60 is the cube root of this number, the resulting number. First, you have to multiply this 3600 by 60, make it a perfect cube, and then find the cube root of this number. That's all. Since it is this number, to see, peculiar thing is that 2,16,000 has 3 zeros. The cube root will end in 1 0. I have only 1 0. For every 3 zeros in the number, the cube root will have only 1 0. That's all. That is how you should think. You already in square roots, you have seen for every 2 zeros in the number, there will be 1 0 in the square root, like that. Here there will be 3 zeros. If there are 3 zeros in the number, in the cube root, there will be only 1 0. That's all. Now coming to the 15th question, it's a choice question. Internal choice is given. This is merely a prime factorization. That's all. You have to resolve into prime factors. You can go through this solution. This question paper has been sent to the students and it's available also. As you can pause this part of this video and just see how you can solve this problem. As we move on to the next question, because this is quite easy, you have to take the triplets, 1 for each triplet. The cube root will have, you underline, you can, for easy way, you can just underline these things. See, 5 into 10. You can group that 11 together and then take the cube root. That's all. The OR question is equally easy. 3 numbers are in the ratio 1:2:3. And the sum of their cubes is 4,500. Find the numbers. Here we have to assume the numbers as x, 2x, and 3x. According to the question, we cube them. X cube plus 2x the whole cube plus 3x the whole cube is equal to 4,500. According to this question, the sum of their cubes. X cubed is x the whole cube is x cube. 2x the whole cube is 8x cube. 3x the whole cube is 27x cube. Add them all. You will be getting 36x cubed is equal to 4500. Divide by 36 on both sides. We get x cubed is equal to 4500 by 36, which in fact is 125, and hence x is equal to 5, which is the cube root of 125. Now the numbers will be 5, because x is 5, 10, and 15. That's all. The numbers are 5, 10, and 15. That's the answer. This is again a similar question already given before. That is, we have to divide which number. Again, it's only prime factorization. See, the prime factorization is important here. It's an important concept where you have to divide. Whenever, see this number 33,275 is ending in 5. It has 5 in the ones digit. So start dividing by 5 first. Prime factors 5 first. Again, if it ends in 5, again you divide by 5. Then move on to 11 and so on. Some other prime factor, so that you ultimately get the 1. You'll get a 1 there, the quotient. 11 into 11 has a triplet. So 11 into 11 into 11. So there is a triplet. So it occurs in a triplet, but 5 doesn't. There's only 1 5 missing. So the smallest number, it has to be divided. So 5 into 5 is already there. So the smallest number by which this number has to be divided is this. If you divide this, these two, see, you have to multiply 5 into 5 is only there. If you divide this by 25, this becomes a perfect cube. 11 to 11 to 11, that's all. So it's easy to divide this. Say 25. And that's the smallest number. This number has to be divided by. And the perfect cube and the cube root of this number, we will be getting 1331 on division. You check the division here, which is 11 into 11 into 11. And the cube root of this number is 11. Section E is a case-based question, a situation. This needed. See, you have to read this question carefully. Forming a cube from a cuboid. A cubical box he has to braid. He has only a cuboidal box. He has to change it in the form of a cube to complete his project. So he needed more cuboids so that he makes it a perfect cube. That's all. So what is the volume of the cuboidal box? You just have to 4 into 2 into 3, 4. That's all. L into B, it is 4 into 2 into 4. So A subdivision is quite easy, 32 centimeter cube. B subdivision. Find the value of 0.02 the whole cubed. 2 cubed, you know, that's 8. And 0.02 can be written as 2 by 100 into 2 by 100, again cubed, you know. 2 by 100 into 2 by 100 into 2 by 100. So you have 8. 2 into 2 into 2 is 8. Divided by 1 followed by 6 zeros. 2 plus 2 plus 2, 6 zeros. Million, 1 million, 6 zeros. So there should be how many places? Decimal places, 6 decimal places, including that 8. So 0 point, you add 5 zeros and then put 8. And this is the value of 0.02, the whole cube. Understood this one? Just go through this. The final question, the subdivision. How many cuboids are needed for this? You have to divide. Now, it's a question of, to make it a perfect cube, what should we multiply? The triplets are that we need for this cuboid. Of course, 2 into 2 is already there. triplet is 2 into 2 into 2. 2 into 2 into 2. So that is this one. So we need to multiply by, this is the cuboid actually. We need triplets. So we need to multiply, we should have to multiply this by 16 to make it a cube. The number of cubes needed. The number of cuboids are more needed. Apart from that one cuboid is already there. So we have how many it is? 16 into 2, 32. So already we have 16 into 2, 32. Multiply 16 into 32 by 16 to make it a perfect cube. So we need 16 more cuboids, not number of cubes, it's number of cuboids. More cuboids. We need 16 cuboids to make it a perfect cube. This is the correct answer. And this question paper is prepared by Mr. M.S. Kumar Swamy of TGT Maths of the Kendriya Vidyalaya. Swamy for having shared this question paper. He is from Kendriya Vidyalaya, Gachibowli, GPRA campus, Hyderabad 32. And he is doing a wonderful job here, sharing question papers to the CBSE students, right from the 7th standard to the 12th standard. A lot of practice question papers, also sample papers are available in his website. There's a link, I will give it in the description, so that I will share it in the description so that you can refer and download some questions from that. That's where I get the questions, and I thank him very much for having shared these questions and with the solutions also. And now so far we have seen some questions, and we are now in this thing, we have seen the questions, solution to certain questions, and we have seen the concepts of cubes and cube roots. Now we are in a position to solve some questions in the NCERT textbook exercises. Already, I will also give a link to the description, link to the video on cubes and cube roots concepts, which already we have presented. Thanks for watching this video. Best wishes from Beta Online Learning. Thank you very much, and have a nice day. Best wishes from Beta Online Learning.